Hey folks, welcome to back to DevOps Easy Learning channel. In this episode, we will cover how to set up an AWS Network Load Balancer, also known as NLB. NLBs are designed for ultra high performance, low latency, and TCP level routing. If you're building VPN servers, you're building backend TCP servers, or anything that is not HTTP, this is your go-to load balancer. Now, for some breakdown of what we're going to do today, we will be creating three instances. Actually, if you look in the accounts, I've already gone ahead, to create three EC2 instances. And in each of these instances, we have installed an Apache web server, and we have set it up in such a way by each server actually looks different. So it will be able to navigate using our network load balancer between each three servers, and we'll be able to see how the network load balancers evenly distributes traffic across these three servers. So for the script to do this, it's going to be in the document folder that we have provided for you guys. You can take that script and you can use it. So when it's time, you can actually practice and have something of a web server that is quite similar to what I have right here. Now, without much ado, let's talk a little bit about network load balance, the load balancer as a whole. So we have there are actually four types of them, with one of them being classified as deprecated, and that is a classic load balancer. We also have another one that is called the application load balancer, which is at the OS level. It's a L7 smart content based routing load balancer. And the one we'll be looking at today is called the network load balance, which is L4 fast IP based, supports TCP, UDP, and TLS. So if you want to know more about this, AWS has a pretty good documentation on network load balances and how to go about setting it. But we, on our own part, we will be, creating one quickly here. And this is how it's going to look like. We're going to create two EC2 instances in our VPC, and we're going to set target groups in front of each one. Or we can, for network load balance, you can actually create one target group and connect that one target group with your network load balancer, so that whenever traffic is trying to hit any of these EC2 instances, it's going to hit the network load balancer, and the network load balancer will evenly distribute the traffic between the two EC2 servers that we have. So every time you refresh, it will provide you, it will direct your traffic to either one of the two EC2 server. Like I said, we've already created three servers that we're going to be using for this test. And now that we've created, the very first thing we're going to do first is that we're going to place these three servers in a target group that our load balancers will be interacting with. And how to create a load balancer target group? It's right here. So you scroll in your EC2 dashboard, you click this. I'm going to open this in a new tab, and I'm going to create a target group, and it's going to be for my EC2 instances. I'm going to name this target group NLB target, and this doesn't really matter. It's TCP for network load balancer. That's what we're going to be using here. So with that, we're going to have it in our default VPC, because that's where we have our EC2 instance running in. Check HTTP, leave this as it is. Click next. And here is where we're going to accept all EC2 instance as it is right here. Oh, I forgot something. But now note this, every time you select EC2 instance, you want to click include as pending below. And we're going to have them opening in port 8080. Okay, include as pending below, port 8080. And you know what? Let's forget about port 8080. Let's just leave everything at port 80. Let's not stress ourselves. and then click create target group. And this is going to take some time to create because we need this total 3 target group to become healthy. Now it's showing that there's 0 healthy and 0 unhealthy. We want it to be able to see all 3. So we're expecting to see healthy number 3 right here. So while this is going on, we are going to just move ahead and we are going to start creating our network load balancer. Hopefully, before we're done with the creation, the target group will be able to see all 3 EC2 instances. Now, let's go back under the same load balancing. You're going to click load balancing. I'm going to open this in a new tab. And I'm going to click create a load balancer. Now, this is not a free service. AWS actually charge for per hour for application load balancer. And just like I was saying before, that there are 4 types of load balancers: the application load balancer, the network load balancer, gateway load balancer, and the deprecated classic load balancer. For this demo, we will be looking at the network load balancer. In subsequent series, we will look at the application load balancer. So for us now, we're going to select create under network load balancer, and we're going to give it a name, network load balancer demo. And it's going to be internet facing because we want to be able to reach it over the internet. If it's for internal purposes and dev testing, you can make it an internal server. But in our case, internet facing is what we're going with. Leave it at IPv4. For the network, we're going to use the default VPC and at least 2 availability zones. So in our case, we want to make sure we pick at least 2 availability zone. In my case, I'm just going to go ahead and pick 4 availability zones. Or you know what, just pick each of. It doesn't matter. Just at least a minimum of 2 availability zones. For the security group, very important. This security group actually tells the load balancer what security network protocol to use. And since we are doing TCP protocol, you want to make sure you select in your security group rule that you have the HTTP protocol in place for your browser. Just to make sure we have that, I'm going to go back to my EC2 instance and confirm that I have that. And if, as you can see, I have all my EC2 instances in the default security group. Let's confirm that. Server 3, security group, default, and server 1, security group, default. So let me open this and make sure I do have the HTTP protocol in there. And this is actually it right here. This is what we want, HTTP, TCP, port 80. Good. Now, with that confirmed, let's go back to our network load balancer. Yes, TCP 80, and this is where you're going to select the target group we just created for our network load balancer. Now, if I click down here, it will show me the target group. And as you can see, it says it's an NLB target group for TCP. If you set it as HTTP, you won't be able to find it here. It won't be able to find because it needs a TCP target group. So select that. And we don't need any listeners for now. We're good on that. We don't need AWS Global Accelerator. It's just testing purposes right here. We're going to click create load balancer. So this load balancer is going to also take a while. You see it's provisioning. While this is provisioning, let's check our target group to make sure that our target group now has this. I'm going to refresh this page. Let's see, it's still not picking it up yet. So I'm going to pause this recording and come back when it is showing me healthy 3. All right, so it took roughly about 5 minutes and for us to get to the 3 healthy state. Just point of note, if you don't see this, then it means that your target group has not registered your EC2 instance as healthy. And if it's not registered as healthy, the load balancer will not direct traffic to it. So this way, we know that our three EC2 instances are ready to receive traffic, and the target group would notify the load balancer about that. Now, let's take a look on our load balancer and see where we are. Oh, yes. Now, it has changed status from provisioning to active, so which means our load balancer is also ready. And take note here, guys, this is what you want. A DNS name has been provided. Now, this is the DNS name that we're going to be punching in our browser as our URL. And with this, we should be able to hit all three EC2 instances. So we won't have to use the IPs of each of these instances at this point, since they are all behind a load balancer. The load balancer would be able to pick each one of these instances uh, with each rotation. So let's go here and take this and go into our browser and punch it right here. And as you can see, our load balancer is pointing to one of our server. Welcome to my first ever custom website. If I refresh this, it's going to change to another server. As you can see, we are on server 2. And if I do it again, as you can see, we are back to the other server 1. And I'm going to keep refreshing it. And every time I refresh it, it's going to be switching between the servers. As you can see, I just switched between all three servers. And guys, for what is what, I want you to you know, take home some very pro tips here, that you want to use your network load balancers for things like VPN, SSH, Redis, RDS, MySQL, Nginx, TCP proxy. This is the load balancer you should use for that. You can use your TLS listeners on your load balancer for secure TCP connection. You can set that up. You can also use your network load balancer to integrate with your AWS private link to expose services securely between your VPC. Also, use zonal DNS names for latency-based targeting. These are just some of my pro tips for you guys, and I hope this was a very informative demo. Uh, and this would wrap up setting up a network load balancer series in AWS. You now understand how to build fast, scalable TCP-based infrastructure. In the next video, we will take a look and go up a little bit and explore application load balancers, where you can actually route traffic based on path, host name, or even headers. Don't forget to subscribe, hit the bell notification, and follow us on our channel, so that way you get updated every time we add a new content. And with that, I say thank you, and I'll see you in the next series.